toy language transcription, which is written in MLIR. Today's episode is about adding structure to toy language. Let's briefly take a look at what it is. Like this, we will create a struct, and it's gonna have one or more variables in the struct. We'll also be able to access the structure by dot notation, like a value.a or value.b, where value is a struct type, and the struct type has a and b value. In this simple language, it just supports float 64-bit type, so there is no type definition here, just a bar here. And this is a struct value initialization. So in this case, we have two tensors of float 64-bit, and we are passing this struct value to multiply transpose user-defined function, and we're gonna transpose each of the tensor and then multiply element-wise. So until episode 11, we have finished it until chapter 6, and today we are doing chapter 7. So I created a diff between chapter 6 and chapter 7. It's all here. I'm going to transcribe code in top-down fashion. So let's start from CMake file. CMake list file first. Dialect parser. So many files we have to change. CMake files here. We have two CMake files. Okay. This one looks like the top level file here. So let's type this in. CMake list file. Oh, before doing that, let me double check if I did code commit. I think I did a code commit. Okay. So from here, one line is removed, but it's just a blank line. Chapter name change it. I'm not gonna change it. Same here. Same here. It's all about chapter name change. Well, we have two additional libraries. Command conversion. After the command conversion, we have dialect. And then, oh, sorry, we have to remove it. Remove it. Okay, done. Next file, it's all about chapter name changes, so I'll skip it. AST. Before doing AST, we are adding abstract syntax type and also parsing code that converts source code into abstract syntax type. So we have to change ast.h, but for now, let's just skip it. How about doing in top-down fashion, like create the canonicalizer pass is added. Create the canonicalizer pass. lowering to affine toy.c. Canon equalizer pass. Funk up. I'm wondering, we already have it? Oh, we have one more Canon equalizer pass. I'm not sure why this is necessary. Shape inference pass. Looks like it's here. Enable opt is lowering to the affine. We have to copy this line here. Y comes twice. The reason I'll ask it to Copilot comes twice is that can change the shape of the operation. By Copilot. Okay, let's continue. Oh, into was added here. Into. Oh no. Done. Dialect.h. Let's briefly see each of them. ast.h. Okay, not so much. Lexer.h. Lexer seems to be easy, so we will start from Lexer and ast, and then ops probably. Okay. Let's just start from Lexer. Looks like we have two internal tokens, keyword tokens. That is, one is a struct and another is number. So let's add them. Previously, identifier was -5, but we needed struct as -5, and identifier became from -5 to -6, and number became -7. Token. Oh, number. We already have number. Talk. Struct. That's 5, 6, 7. And then get token is checking whether the identifier string is def, return, or var. We're going to check if it is a struct. Get talk. Get talk. Struct and return struct. The code we're checking if the last character is point is removed. I'm not sure why. Oh, I see. It has to start from just a number, and then point can come later. Looks like it was bug. Okay, we are now at ast.h. We'll go to ast.h. In the var type, we should have a string name. Var type. We should have a string name. Why? Let's take a look at it. Var type is a variable declaration. It looks like this name is going to be removed. Okay, let's see. expl.ast. Basically, a block is a list of expressions, and we are having additional expression called expl struct literal. I guess it's for creating struct with literal, as we have seen like this. This one, struct literal. expl.ast. And then we have right above variable expl.ast, we need to define struct literal expl.ast. We have to define this one. Struct value. expl.ast is base class, so we should call the base class constructor. The class name. And then okay. Because this struct literal is going to have values. For example, the first value and the second value. strings. Return values. And RPTI article class of const expr ast c return c get time we have a default initializer for variable declaration, variable expression declaration, variable declaration expression. St should be initialized as null ptr. We need to understand why null ptr is necessary. Then why null ptr. Oh, we still have more. So prototype AST, this is wherein we define our user-defined function. This part is the parameter declaration part. It's a prototype AST, name and args. Actually, it should be parameters. So the type is changed. Variable expl_ast will be replaced with the variable expression ast. Let's take a look at the difference. Variable expl_ast expression class for returning a variable. Okay. Previously it was just accepting variable name, but right now we should be able to accept variable declaration like a struct something like we have seen here. Okay, let's see. Previously our function definition was just having variable name like this, but now it's just a variable name is not enough information, so we need a variable declaration like this. So we are changing variable declaration. Lexer ast. So we are changing variable expl_ast to variable declaration expl_ast. One more here. And then we have a new type called the record ast. Right before function ast. Record ast. record AST is a superclass of function and struct. Very kind class. Oh, that's good. Record AST time. And then private. Function AST. So function AST's base type is record AST. So record AST record function. And we have RTTI style. Function. And finally we have the struct AST. I have seen something like this before. What was it? Struct AST. Oh, here. So struct declaration is semantically similar to prototype AST. Public. We have several helper functions: destination, LC, return location. This one. In the module AST, we have to change the function AST into record AST. So a module is going to be a list of record AST instead of a function AST, because we should be able to define struct as well as a function. Struct and function, all these are records, and the module, a module is a file. It's going to be containing a list of record. Module AST. Begin and for the iteration. And finally, we are done with the AST.h. It's time to do parsing. ops.td parser.h. Looks like ast.cpp. Let's finish this one first. It's just a small amount of code change. Looks like dumping functions are added. 함수 is Korean. ast.cpp here. Literal. Oh, it's a bit hard. I don't know Windows. EST. Print, return, right? The return we have struct. Init bar. We're gonna create a init bar. We're gonna dump init bar. Only if get init bar. Only if it is not null. If it is not null, we'll dump init bar. And then right before variable expl ast AST, we have we do VM. Actually, this is first time for me to type AST.cpp because I skipped it in the second chapter because I thought I was quite familiar with this file. So looks like this is a for struct type. Print a struct right before module AST. Okay. And finally, we have a module ASD. Here we are checking if it is a type of a function ASD, and also we are checking if it is a struct ASD with the dynamic typecasting. So instead of F, we have a record, and then we have to check if function ASD dynamic cast function ASD get then dump struct else no. Okay, here I found a typo. I create a pull request here. We're done with the ASD, so I have to type in parser. I come back soon. I have to go to gym, so I come back soon. Thank you.